Hello, class. Welcome to Math 131, Objective 6. In this objective, we are going to look at how to evaluate polynomial functions. But first, we need to talk about some preliminary information. So first and foremost, we need to talk about what a polynomial is. A polynomial can be a variable expression in which the terms are monomials, okay? And a polynomial that has one term is what we call a monomial. That could be like 5x. A polynomial that has two terms, we call that a binomial. And that could be like 5x squared y plus 6x. You see those two terms. A polynomial that has three terms, we call that a trinomial. And in this example, we see the three terms here, okay? Now, any other polynomial that has more than three terms, we don't have a special name for it. We just call it a polynomial. So now let's talk about the degree of a polynomial, okay? So when we have a polynomial written out, whether it's a monomial, binomial, trinomial, or just a regular, polynomial, the degree is the greatest of the degrees of any of its terms, okay? So if we look at these three examples right here, these are written in a certain order, which we will talk about next, but the one with the highest degree is in the front, okay? So if we look at the first example, the degree of this is 1. The degree of this is 0, okay? So we write it with the highest degree in the front, and then they decrease from left to right. If we look at example 2, the degree of this one is 2, the degree of this one is 1, and the degree of this one is 0. So the degree of the whole polynomial is that one that's the highest. If we look at this one has two terms, so it is a binomial. The degree of the first term is 5, and the degree of the second term is 4. So the degree of the whole polynomial is going to be 5, okay? Now this order that we have these in, this is called descending order, okay? The exponents on the variables decrease from left to right. And these are just some more examples, okay? The degrees here is 2, 1, and 0. So they are, they decrease from left to right. If we look at this one, the degree is 3, 2, 1, and 0. So this is the standard of how we want to write our polynomials, okay? We want them in descending order, meaning that the variables will decrease from left to right. So now let's talk about the leading coefficient, all right? The leading coefficient of a polynomial function is the coefficient of the variable with the largest exponent, okay? And the constant term is the term without a variable, okay? So if we look at example 1 is already in descending order, okay? If we look at the 4 terms we have, the degree goes 4, 2, 1, and 0, okay? So it's already in descending order. So let's identify the leading coefficient. The leading coefficient is the coefficient of the variable with the largest exponent. So that would be this 7 here. All right. The constant term is the term without a variable. That is the -4. All right. And the degree is going, since it's already in descending order, the degree of this first term, or the term with the highest degree, that degree is 4. Okay. So the leading coefficient is 7, the constant term is -4, and the degree is 4. Let's look at example 2. We got 3x minus 7x squared plus 5, and we're going to put it in descending order, okay? That means that we need to start with identifying the degree, okay? So we know the degree of the 5 is going to be 0. The degree of the -7x squared, that exponent of 2, is going to help us with that. And for the 3x, the exponent is 1. So we have to put it in order from greatest to least, okay? So the -7x squared goes first, then it's the plus 3x, and then plus 5, okay? Now that it's in descending order, we see that the leading coefficient is -7, the constant term is 5, and the degree is going to be 2. All right, let's do one more. We got 3x to the 4th minus 7 minus 2x plus 4x squared. First, let's identify the degree. The degree here is 4, this is 0, this is 1, and this is 2. So if we put those in order, the first one is going to be 3x to the 4th. Then we're going to have plus 4x squared. Then we're going to have minus 2x. Then we're going to have minus 7. So now we can see that our leading coefficient is going to be 3. The constant term is -7, and the degree is going to be 4. All right. So now we're going to go into our next part. So now let's transition into functions. Okay, so these are 3 types of polynomial functions, what the function kind of looks like, and what the degree would be. So if you took Math 130, in that class, we looked at linear functions. That is f of x equals mx plus b, which has a degree of 1. In this class, toward the end, we will be looking at a lot of quadratic functions, okay? With that function, we have f of x equals ax squared plus bx plus c, and we have to make sure that a does not equal 0. Now, this has a degree of 2. Now, cubic functions, we won't really get a lot into those, but a cubic function is f of x equals ax cubed plus bx squared plus cx plus d, and a cannot be equal to 0. And the degree of that, of course, is a cubic function. The degree is going to be 3, all right? So with getting into functions and this function notation, now we can start evaluating polynomial functions. All right, so let's look at how to evaluate polynomial functions, all right? We have evaluated before, so this should be familiar. Again, I said this is a recap, But whenever we evaluate, we basically have a function and a value that is given that we have to plug in and simplify, okay? So if we look at example 1, we have P of x equals x cubed minus 3x squared plus 4, and we want to know what P of negative 3 is. So to find that, P of negative 3, we're going to plug in negative 3 everywhere we have a x, all right? Now for this example, I'm going to do this the way that most of you all try to plug this in. And for my next example, I'm going to show you my recommended way. But as you saw, I did make sure that everywhere I had an X, I plugged in a negative 3 and I made sure to put it in parentheses, okay? That is going to help you make sure that you do not mess the problem up. From here, we follow the order of operations. Negative 3 cubed is going to be negative 27. And then we have another one that has an exponent. So we're going to do negative 3 squared, which is going to be positive 9. And we're going to bring down the plus 4. All right. We're going to continue to simplify. We have negative 27. Negative 3 times 9 is going to be negative 27. And we're going to bring down the plus 4. So in all, P of negative 3 is going to be negative 27 minus 27 plus 4, which is going to be negative 50. Okay? Now for the next example, I'm going to do my recommendation. It is my recommendation that you rewrite the problem but leave a gap where that variable is. This is going to help you make sure that you plug into parentheses, okay? A lot of times when you try to write it as you go, you miss something or you forget the parentheses or, a lot of different things can happen. So if you rewrite the problem and use the parentheses as like a placeholder for the X and then go back and plug it in, it's like a guaranteed way to make sure that you plug everything in correctly. Then you need to follow the order of operations to simplify everything, okay? So when we do that, we will have negative 2 times 16 minus 5 times 8 plus 4 minus 8. Then we will simplify again, do some multiplication. We'll have negative 32 minus 40 plus 4 minus 8. And when we simplify that further, we will find that R of 2 is going to be negative 76, okay? So that is my recommendation to you on how to plug in everything properly. Then you follow the order of operations. Remember, it is PEMDAS. All right. The P is for parentheses, brackets, anything happening in a group. And it has to be an operation happening inside of those parentheses. A lot of people blurt out parentheses and there's no operation, okay? So when we do parentheses first or brackets first or the numerator first or the denominator first, anything like that, it has to be an operation happen inside of there. That's what we are doing first, the operation inside of those parentheses, all right? So let's get through our next two examples. For example, 3, we have R of x equals 2x cubed minus 3x squared plus 4x minus 2, and we want R of 2. So I'm going to rewrite it, leave those gaps. Then I'm going to go plug in the 2. All right. And then we're going to just simplify everything. All right. I'm going to for this one and the next one, I'm going to just write it out for you all. So just follow along with me on the screen. All right, so that is how you finish those last 2 examples and how you evaluate polynomial functions. And that completes objective 6 for Math 131.